Between July 2025 and July 2026, the React and Next.js ecosystems executed a structural pivot. The engineering focus moved away from human-centric boilerplate toward automated systems. React transitioned from a library requiring manual performance optimization into an automated UI engine. Next.js made a corresponding shift. It abandoned implicit caching mechanics in favor of an explicit infrastructure built specifically for AI agent comprehension. To see how this architecture works in practice, we will use a test subject, Modicum, a multi-tenant B2B application. This system has strict engineering requirements, uncompromising role separation, server-side data fetching, and secure PDF routing. Building these systems manually requires a slow, deliberate implementation cycle. An AI system, however, iterates these code structures at high velocity. To support this iteration speed, modern frameworks must now output structured telemetry that an AI can instantly ingest. This inversion of the development loop shifts the focus of senior engineering. The primary task is now to strictly define the architectural boundaries that the AI must respect. The base of this modern stack relies on React 19.2 and the React compiler. The compiler eliminates manual performance tracking. Handwritten use memo hooks are obsolete. Instead, it parses the component tree at build time, automatically calculating memoization dependencies. If an invoice status updates, the compiler isolates that exact change. Surrounding rows remain completely static. For a multi-tenant application like Modicum, this automated memoization is a structural necessity to scale massive project tables without performance degradation. Writing standard React code now yields maximum performance without human micromanagement. By making UI optimization an automated build time given, the ecosystem frees the developer to focus entirely on system architecture and data flow. Moving up the stack, we reach the Next.js routing and caching layer. Next.js abandoned implicit caching to prevent catastrophic data leaks between users. It now uses the use cache directive as a structural wall, separating common layouts from sensitive, tenant-specific data. This guarantees Client A cannot inadvertently access Client B's cached response. At the network ingress point, the standard has also shifted, replacing the older middleware file with a refined proxy.ts. Proxy.ts operates strictly as a perimeter guard. It identifies and redirects unauthenticated traffic, but it does not act as a data gatekeeper. Granular data access remains strictly the domain of API route handlers and database-level security policies. Next.js 16 replaced ambiguity with a deterministic infrastructure. Developers are forced to explicitly architect their data pathways. At the infrastructure level, deployment parity has been solved by the stabilization of the Next.js adapter API. This standardizes the bill of contract. It decouples deployment from Vercel-only infrastructure and eliminates the need for host-side reverse engineering. Inside the local development environment, TurboCac eliminates fast refresh latency, enabling the high-speed iteration required by AI systems. Next.js 16.2 integrates the Model Context Protocol into DevTools. Projects now use an agents.md file, injecting immutable systemic rules directly into the AI's context window. The AI uses this telemetry, server logs and DOM diffs, to bypass human guesswork entirely. It uses this immediate data feed to implement and validate its own DOM fixes directly in the browser. The autonomous AI agent has effectively become the primary consumer of a framework's internal telemetry during the development cycle. While UI rendering and framework boilerplate are now highly automated, critical bottlenecks remain in the pipeline. Multi-tenant security boundaries remain an exclusively human responsibility. The late 2025 React Server Components vulnerability, a maximum severity CVSS 10.0 exploit, serves as a strict reality check. Automated pipelines cannot substitute for human-driven patching against zero-day exploits. Down the stack, configuring database row-level security is an architectural absolute, untrustable to AI. Protecting the Supabase secret key through secure environment variables acts as the final, unautomatable failsafe. The daily workflow of an engineer today looks completely different than it did just 1 year ago. Modern architects now focus their efforts on engineering the secure, explicit boundaries that an AI agent is required to follow.